Alright guys, well, welcome to this video. And this is actually going to be the main lesson for today's class. So we're going to be talking about triangle congruence and how we can exactly prove that two triangles will be congruent to each other. Before we start, I want to make sure you have this handout in front of you. It's double-sided and has all the stuff that I'm going to be going over with you on this video. So make sure you pick this up from the front table, as all the physical worksheets are for today. They're going to be sitting on the trapezoid-shaped table in the front of the classroom. And with that being said, let's talk a little bit about triangles. So we're going to introduce another theorem here to you that is something that probably makes sense to you as you're looking at this. So it's called the third angles theorem. And so basically what it's saying is if two angles of one triangle are congruent to two angles of another triangle, well then the third angles automatically have to be congruent to each other. And so basically I'll use some numbers to kind of make sense of this. So if we look at the third angles theorem, let's say, for example, this is not a formal proof, but an informal way to show this to you. If angle A was 20 degrees and angle B was 100 degrees, well, obviously by the markings in DEF, angle D automatically would have to be 20 degrees, and likewise angle E has to be 100 degrees. So the third angles theorem is pretty much automatically saying that, hey, C and F have to be congruent to each other since I have two pairs of congruent angles. And by doing the math, you're going to see that these add to 120, which means this has to be 60, and likewise, this has to be 60 as well. So it's sort of an obvious proof, but it's something that you will be able to use and you're going to have to use eventually when we are doing proofs. Now, speaking of proofs, if we look to the second slide here, what it's actually asking us to do here is we're going to do our first triangle congruence proof. Now, what it's basically saying is I'm giving you a lot of stuff in the given. All right, and I need to prove that triangle ACD is congruent to angle CAB. Now, if you watch the previous video I talked a lot about how you need to show that three pairs of angles and three pairs of sides are all congruent. And if you haven't watched that video yet, you need to go back and check that out to make sure that you understand what I mean by congruent triangles. So that's what this proof is going to need to consist of. This proof is going to need to consist of 6 different congruent statements, okay? 3 pairs of sides and 3 pairs of angles. Well, the good news is I wasn't too mean with this proof. I gave you a lot of them right in the given. So let's go ahead and write those in first, as we would with any proof. So we have 2 sides right there that are congruent. I have ACD is congruent to CAB, and all of this is marked on the drawing, so I'm not going to have to remark anything here, okay? So those are all my given statements. Now what I'm missing is 2 particular things. Remember, I need 6 things to prove congruence here. So one side. Oh, I'm missing a side, so we'll have to talk about that. One angle, I'm missing an angle as well. So those are the 2 things we actually need to spend our proof here looking at. So AD is indeed congruent to CB, and DC is definitely congruent to BA because I told you. The missing side of this triangle that we don't know is AC. And the missing side on this triangle we don't know is AC. So AC would need to be equal to AC. So I would have to say this. It seems kind of obvious. There was a property that we actually learned about earlier in this course. We long forgot it because we haven't used it. That says a number is equal to itself. So we had said like, oh, it's kind of obvious that 5 is equal to 5. Well, this is now a time where this statement is really helpful, because now this gives me my third pair of sides that's congruent. But what am I going to call this? Well, if we look back to chapter 2, we called when something's equal to itself the reflexive property, which is exactly what I'm going to do here. I'm going to write the reflexive property as the reason AC is equal to itself. So, 3 sides, 2 angles. Well, I've got to find the third angle. But if you go back to the first slide, we talked about what's called the third angles theorem. And so I'm able to right away go ahead and claim that angle D and angle B would have to be congruent, because if these 2 are congruent and these 2 are congruent, kind of like this example back from the last slide, I can automatically say D and B are congruent, and that's going to be our new third angle theorem, okay? And so last but not least now, we officially now have our 6 statements. We have our 6 statements of congruent. 3 pairs of sides, 3 pairs of angles. So I can conclude that ACD, or triangle ACD, is congruent to triangle CAB. And that's essentially by the definition of congruent triangles. Now, the pro and con to this first proof is, well, I gave you 4 of the 6 things right off the bat. Had I not done that, this could have been a very long, painful, and excruciating proof. So, are we going to always have to show that all 6 parts of the triangle are congruent? And so this leads back to what we talked about yesterday, or should I say what you cut out yesterday. Yesterday, you were given a task, and you were asked to cut out a bunch of triangles out of construction paper. And I didn't give you all 6 things, because had I done that, you all would have come up with congruent triangles to each other. That's the purpose of congruence. All parts are congruent. All pieces and parts are congruent. But I didn't do that. So let's look at some of the ones you guys came up with here. So we're going to skip back here to the beginning. Okay? The very first one was the SSS. Okay? So I gave you 3 side lengths. I told you nothing about the angles. If you look at the drawing up here, and again, some of these are, remember, not 100% perfect because you were doing them fairly quickly, but look at all those orange triangles. From both classes, you guys all were able to draw almost the exact same triangle. And all I gave you was 3 side lengths. And you didn't need to know the angle lengths. So that's a helpful little shortcut that we're going to be using in this lesson. On the other hand, the yellow one, AAA, I gave you 3 angle measurements. Do any of those look the same? Well, maybe these ones up top here, but really, realistically, no. You guys did not come up with consistent, congruent shapes here. So if I give you 3 angles, I don't think that's very helpful. Moving on to some of the other drawings. SAS, again, there's a couple here right in the middle that I'm moving my mouse over that I don't agree with in terms of measurements, but like these 4 and these right here and these right here were definitely measured properly. They all were congruent to each other. And so if I give you 2 sides and an angle between those sides, it's going to work. SSA, on the other hand, does not work. There are 2 clear different types of triangles you guys created. These tiny skinny ones and these rather large ones. Okay. Now the difference between these 2 on left to right side, and your notes will say this when we review them in a few moments. I gave you 2 side lengths in the blue, and I gave you the angle that was between those sides. So essentially the adjacent one. But in the green situation, I gave you 2 sides, and I gave you an angle that was not in between those sides. So you see the difference. If I give you SAS, it works. If I give you SSA, it does not work. Okay? Try not to reverse that ever, as you might see. Moving on to the last couple. ASA and AAS, again, 2 angles in one side, those both worked. These pink/red triangles are all congruent, and all of these white triangles are congruent. So in the situation on the left here, when I give you 2 angles and a side that is between those 2 angles, it's going to work. However, over here, in the white, I give you 2 angles and a side that is not between those angles. It also works. And part of the reason for that is the third angles theorem. So if you take a look at that, that might make a little bit of sense. And the last weird one is hypotenuse leg. That's what HL stands for, hypotenuse and a leg. What I did was I asked you guys with a right triangle, and I gave you the length of the hypotenuse and the length of one of the legs of the triangle. This is the hypotenuse, and from what I remember, this is the leg I gave you. So that was enough information to prove that all these purple triangles are congruent. So of the 7 that you guys cut out, 5 of them yielded perfect congruent triangles. The 2 failures was SSA, again, don't reverse it. I say that to help you remember it. And AAA, AAA. AAA does not work, and SSA does not work. But the other 5 do, which lead back to our notes. So in our notes here now, we're going to skip over that. We already did it. SSS. If 3 sides of one triangle are congruent to 3 sides of a second, then the 2 triangles automatically are congruent to each other. Side angle side. So this was the trick. If 2 sides of the included angle, I'm going to grab my highlighter so that we can look at this, are congruent, and the included angle, that is so important to this because that's the difference between SAS and SSA. Okay? The included angle is congruent, then the two triangles are congruent. So all you need for SAS is two sides, two pairs of sides that are congruent, and the included angle. Moving on, hypotenuse leg, that's the fact that the hypotenuse and the leg of a right triangle. Those are the three things you need. You need a pair of congruent hypotenuses, a pair of congruent legs, and a pair of right angles. That's your hypotenuse leg. And the last few, ASA, two angles and the included side. So notice how AC is between the two angles, and so is DF. That's why this works. And last but not least, we have angle, angle, side. If two angles and a non-included side of the triangle are congruent, notice how this is not in between the two angles that you know, then that would be called AAS. So we're not going to have to, when we do proofs, prove all 6 things are congruent. I can use one of these 5 shortcuts to help us do that. And that's what part 3 of today's class is going to look at, is more of the proof aspect to things. So in the last couple moments here, as we look through this video, what we need to be able to do is look through some different examples and be able to make the decision and say, hey, will these two triangles be congruent, and which of these new theorems, these 5 shortcut theorems I will call them, can I use for it? Let's look at 1 or 2 quick examples to wrap the video up. Alright, so we're going to take a look at these 2 quick examples, and we basically need to determine, is there enough information to prove the triangles are congruent? So we're going to look at triangle ABC and triangle CDE. Okay? So first things first, these 2 angles are congruent, B and D. AB and ED are congruent because they are by the marking here. So we have a side and we have an angle that are congruent. But now I have to decide, well, is there anything else in this drawing I can assume? I can't assume these are congruent because I don't know anything about these lines being parallel. Had I known that, and actually we might be able to go down that path actually because these are alternate interior angles, but we're not going to go make it that complicated because there's something more obvious in this problem. As I see here, this angle and this angle are vertical angles. And so I can right away say that those are congruent because we can assume vertical angles. So this is going to be, yes, congruent, and it's going to be congruent by, well, A, and S. The S is not between the 2 angles, so we would call it AAS. Had that side been there, we would have called it ASA. That's the difference between the 2, and you'll get better with this as you start practicing this in the next day or so. Okay? Last but not least, over here on number 2, the last example, you have a right angle, so those are clearly congruent, so that's a good check mark. Let me get a different color here. So check. I have a pair of sides that are congruent here and here, and I have another pair of sides that's congruent here and here. So again, this is going to be congruent, but it's not congruent by hypotenuse leg like some of you may be thinking. In the case here, yes, there is a right triangle, but in order to use hypotenuse leg, you would have to know that the hypotenuses are congruent, which I don't know. This is actually going to be SAS, side angle side. I know a pair of angles, and that pair of angles happens to be between the 2 pairs of congruent sides I was giving, pair 1 and pair 2. And that's how I can make that conclusion. So there are 2 worksheets here as well that are, the electronic versions are on Canvas. The physical copies are on the front trapezoid table. Feel free to pick those up. One of those I do have an answer key attached so that you can instantly look over how you did and see if there's any questions you have. You may work with people at your table. Again, keep an eye on your time and that you need to work on an additional task from this as well. After you've finished both of those worksheets, we're going to move on to the last part, which talks briefly about proofs. Thanks for watching.